In the last video, we had word problems and we solved proportions. And I'm going to do the same thing again, but I'm going to use something called a tape diagram. So I'm going to start off with a tape diagram of a problem that was very similar to what we had in the last video. And then I'm going to show you how tape diagrams can be useful when you're using a part to whole ratio and you're trying to find different parts that are unknown. So I'm going to show you how this works with what we did in the last video. So I'm going to show you first how we did it in the last video, and then I'm going to show you how to do it with a tape diagram. So in this problem, we have a ratio of small to large dogs is 4:3. Make sure my colon is large enough. There we go. 4:3. If there are 24 large dogs, how many small dogs are there? So in the last video, I had us set up 4:3. So 4 small to 3 large. So if I have 24 large, how many small would there be? I know that 3 goes into 24 8 times. So 4 times 8 is 32. All right, or I can do 4 times 24 divided by 3 and get 32. So how would I do it with a tape diagram? So a tape diagram is actually little boxes, and we call it a tape diagram because in a tape measure, all the pieces are the same. So in a tape diagram, all of my boxes are going to be the same. So if I have small to large is 4:3. So I'm going to draw 4 boxes for my small and then 3 boxes for my large. All right, so there's my ratio, 4:3. I know that there are 24 large dogs. So all 3 of these boxes are going to equal 24. So 3 what's make 24? 3 eighths. So since my boxes down here are the same size as the boxes up here, minus my drawing ability, I have 4 eighths. So I know that I have 32 small dogs, which was what I had in my proportion problem that I had before I erased it. So why would I use a tape diagram to solve proportion problems? So let's look at another example where I've got a part-to-part relationship, but then I only know a total. Here's an example where a tape diagram will be very helpful as a visual of what is going on. So here we have the ratio of red to blue pens is 2:5. If there are 70 pens in a package, how many are red, how many are blue? So let's go ahead and draw our boxes for our red and our blue pens. So red is 2 and blue is 5. And again, we'll make our boxes as close to equal as possible. Okay, so here we've got 2:5. We know in the whole package there are 70 pens. So in this whole package, I have 70 pens all together. So if we think about this, I have 1, 2, 3, 4, 5, 6, 7 whats make 70. Well, 7 tens make 70. So each of these boxes get a 10. So now I have 70 all together. So now how many red pens do I have? I have 20. And how many blue pens do I have? 50. Because 20 plus 50 is 70. And 20 to 50 is equivalent to 2 to 5 when we have that in simplest form. So that's a helpful way on why we would use a tape diagram measurement in order to solve this proportion problem. Okay, here's our last example with using tape diagrams to solve proportion word problems. So here we have the ratio of boys to girls is 3:5. If there are 20 more girls than boys, how many total students are there? So let's go ahead and draw our original ratio that we have going on. So boys is 3 and girls are 5. All right, I know there are 20 more girls. So that means this portion right here and off to the right is going to be 20 more. So this is where my 20 more girls is going to come into play. So if I have 2 whats make 20, 2 tens make 20. So again, since all my boxes are equal length, that means every single box is going to be 10. So that means I have 30 boys and 50 girls, which 30 to 50 in simplest form is my 3 to 5 that I had in my original problem. And 50 is 20 more than 30. Now the question is asking how many total students are there. So total altogether is going to be 30 plus 50. So altogether there are going to be 80 students in this problem, where the ratio of boys to girls is 3 to 5, and there are 20 more girls than there are boys.